Hi everyone, in this video, we're going to embark on a fundamental journey into one of the most crucial concepts in programming, loops. What are loops and why do we need them? At its core, a loop is a control flow structure that allows a block of code to be executed repeatedly. Imagine you need to print hello 10 times, or process every item in a list of 1,000 customers. Writing the same line of code over and over is inefficient and error-prone. Loops solve this by letting you define the action once and specify how many times or under what conditions it should be repeated. In Kotlin, loops are considered one of the basic building blocks that you will encounter throughout programs. They are crucial for applying logic to data structures and handling various iteration scenarios. Types of loops in Kotlin. Kotlin supports the usual set of loop constructs found in most programming languages. The primary loop types we'll explore are: for loop, primarily used for iterating over collections, ranges, and anything that provides an iterator. While loop repeats a block of code as long as a specified condition is true. Do-while loop, similar to while, but guarantees the code block executes at least once before checking the condition. Let's dive into each one. The loop, iterating over collections and ranges. The for loop in Kotlin is particularly powerful and flexible. It's designed as a for-each loop. This means it can iterate over strings, data structures like lists, sets, and maps, and essentially anything that has an iterator. You can also iterate over objects that define an extension function named iterator. When you can iterate over all the values in a range, such a range is called a progression. Let's look at some examples. Basic loop with a range. The most common use of the for loop is with ranges. A range defines an interval with a start and an end value. Example: printing numbers from 1 to 5 inclusive. One, 5 creates a range from 1 to 5, including 5. Here 1. 5 creates an inclusive range. The operator always includes the end value. If you want a range that does not include the end value, you can use the until function. Example: printing numbers from 0 up to, but not including, 5. Iterating in reverse order with. What if you need to count backwards? Kotlin provides the down to function for this. Example: counting down from 5 to 1. Customizing steps with. You can also specify a custom increment or decrement value for your loop using the step function. Example: counting from 0 to 10, skipping every other number. It's important to note that when using a step, the last element might not be included if it doesn't align with the step value. For example, 3. 6 step 2 would print 3 then 5, but 7 would be outside the range. You can combine down to with step as well. Example: counting down from 10 to 1 with a step of 3. Iterating over other collections. The for loop isn't limited to numbers. It works seamlessly with other data structures. Strings. The string class provides an iterator function, which allows it to be used directly in a for loop. Lists and maps. When iterating over maps, you can use destructuring declarations to easily access both the key and value for each entry. Performance note on loops. A great benefit of Kotlin's for loops, especially with integer ranges, is that they are highly optimized. When compiled for the JVM, these for loops are translated into index-based for loops, similar to what you'd write in Java. This means there's no performance penalty from creating extra iterator objects. This highlights Kotlin's pragmatic approach to language design. The do-while loop is a variation of the while loop. The key difference is that its code block is executed at least once before the condition is evaluated. Example: simple do-while loop. Condition is false, but the loop runs once. While and do-while loops are available, Kotlin often offers more idiomatic ways to achieve iteration using range-based for loops or higher-order functions on collections, which you might find yourself using more frequently. Loop control keywords: break and continue. Inside any loop for while do-while, you can use special keywords to alter the loop's flow. Break. This keyword is used to terminate the enclosing loop immediately. The program execution then continues with the statement immediately following the loop. Continue. This keyword is used to skip the current iteration of the loop and proceed to the next loop step. Combining loops with expressions. While not a loop itself, Kotlin's powerful when expression can often be used in conjunction with loops, or even replace simple else if chains within loops, making conditional logic very concise and readable. You can use ranges directly in when branches, which can implicitly handle cases that might otherwise require loops or multiple conditional checks. Example: using when expression with ranges in a loop. Okay, all right, guys. We have seen about loop in Kotlin. In our next video, we'll dive into Kotlin's next component. So see you guys in the next lecture.